welcome from Anthropic, Eric Burns.
Hi, folks. Thank you for coming. I'm Eric. I'm a field executive architect, which everybody else calls a field CTO at Anthropic. I'm a bit of an odd choice to give this presentation. I'm an old guy from the world of traditional computing and enterprise SaaS. And I'm not an AI engineer, and I'm not really an expert in the field, but I spent 2 years immersed at Anthropic, and that'll smarten anybody up a little bit. Before Anthropic, I was the founding CTO and eventually became the CEO of an enterprise software company called Panopto. It helped customers build and manage huge searchable video libraries. And I worked in the trenches of enterprise SaaS at every level, from cloud architecture to user experiences to cross-platform integration. And this gave me a chance to see how large enterprises work with their systems of record, and how important the integrations are between enterprise systems. And I came around to the perspective that integrations are arguably the most important part of the product, and great ones feel like they are the product. And the user experience across systems in these great products is seamless. But at Anthropic, I have the benefit of having done something pretty exciting early in my tenure. I was the product manager for the first incarnation of our labs team, and I had the honor of helping to launch MCP and Claude Desktop as our first MCP client and an early preview version of Claude Code. And when Anthropic announced MCP, I helped position it as a fundamental technology, as a bridge between enterprise systems of record and frontier AI models, a way to ground Claude's incredible reasoning skills in real context. And this gives me the opportunity to kind of try to interpret what's happening today through the perspective of a career enterprise software guy rather than an AI insider. And just to get some disappointment out of the way, I think what happens after software is just more software, a lot more. But I think today what we can do is explore what's happening at the intersection of frontier AI and enterprise SaaS. So first, I want to give everybody that doesn't have yet just a little bit of foundation on who we are at Anthropic. We pioneered safety research, such as interpretability and constitutional AI. And we did this because we believe that our mission is to ensure that the world safely makes it through transitions to transformative AI. Our models consistently lead the MASC benchmark, which measures honesty when the model is pressured to tell lies about things it knows it's true. And we're at the forefront of research and understanding models, aligning them, and making them resistant to things like jailbreaks and misuse. And I can't really do justice to Anthropic's origin story, but I think it's safe to say that our founding team had a really strong conviction that the best route to frontier intelligence was through safety. And I think that insight has served us really well, and it's helped to achieve consistent progress on pure intelligence while continuing to raise the baseline of overall safety in AI. And this has led to an explosion of success in enterprise software. It's actually the fastest scaling product category, software product category in history. And this is a bit dated now, but in 2025, the whole category was driving almost $40 billion in revenue. And we've had a good run over the last couple of years at Anthropic, coming from a relatively small market position in enterprise API back in 2023. We've consistently made progress along with our friends here at Google. Thank you for hosting us here. And I think that as the market has grown, we've kind of become identified as one of the major enterprise players. And the real exciting story under the numbers there is that we're continuing to succeed in the coding market in particular. We've had, I think, something like 18 months at the top of the coding leaderboards, which is extraordinary in a relatively young field. And so not all of this is through Claude Code, our coding agent. A lot of it is through other partners' agents and different pieces of software that pass through our models. And we began life as a frontier lab. We were trying to build safe, intelligent models. And as we started to succeed at this, we began to build a platform. And so that platform became a high availability global system that people can use to develop software on top of Anthropic models. And as we started to learn what the models were good at, we began to have some conviction about what would make for great products, not just great platforms. And so we created the Claude Enterprise product and platform. And this is really about turnkey software that people can deploy at scale in enterprise and begin getting value from right away. And all of this is stacked up into this kind of architecture slide here, which is the full stack of what we offer at Anthropic. At the baseline are the clouds and our cloud partners. Thank you, GCP. And then on top of that, we create our models. We really just have 3 models in our series, setting aside Mythos: Opus, Sonnet, and Haiku, which is small, medium, and large. And for those that haven't used Haiku, it's really a treat. It's incredibly, incredibly fast. And on top of that, we build our platform, and then finally our applications, which are really about delivering business outcomes rather than delivering specific experiences. And so we've had a pretty exciting run of shipping these products. The first one that we created for enterprise was just simply chat. It was being able to interact with the models, and in particular, to be able to pull in data from external systems. And so now chat is one of the primary ways that people interact with corporate MCP servers, and they work through conversations and, as a thought partner with their real data. And in 2025, we released Claude Code. And for those that have used it, kind of the rest is history. But this was a bit of a breakthrough because it combined the model capability with the ability to use computers as computers, to interact with the shell environment, to write and execute code, to do things beyond what could just happen in a conversation. And that proved to be so useful for people that weren't engineers that we wrapped it in a product called Cowork. And so if you haven't taken Cowork for a spin, I encourage you to. It's basically Claude Code in a friendly wrapper running inside of a VM on your laptop. And so you can do all kinds of things that sit at the intersection of models being very smart and being able to work with lots of context, and also being able to write and execute code and create intermediate work products and do data processing. And so all of this has brought us to kind of a perspective on how enterprises can use AI. And we call this the 3 pillars. The first pillar is making employees smarter. It's giving people better access to information, giving them a thought partner that can work through complex ideas, just being able to be more effective in their day-to-day jobs. In turn, that leads to an organization developing some intuition for how to work with AI. And so you begin to start looking at the processes that you're running and seeing opportunities to make them more efficient, either by coding more effective solutions or by introducing agents, or just finding ways to kind of wring out the slack and the inefficiency and things that every big company does every day. And as these 2 begin to take root, the intuition of working with the products and the experience of building better, improved processes, you begin to see opportunities to leverage AI to do things that are more transformative, to create entirely new products and new revenue streams. And this is, I think, the most exciting opportunity collectively. It's not just to iteratively improve what we have, but to create things that are entirely new, that couldn't exist without AI. And so, this is next. I'm sure every other presentation has an exponential in it somewhere. And that's a very abstract concept. It can be a bit hard to visualize. And so I want to show you a video that released, it's out on YouTube now, and it just kind of puts the progress that the coding models have been making in context. So let's take a look. All right, I'll try to interpret that a little bit. That is a demonstration of incredibly rapid progress over just a couple of years, from a model that could barely write code that would work, to models that could use tools, to models that could operate in a harness, to finally coding agents that are capable of replicating an extremely complex, multi-state, single-page React app. Effectively, Claude AI, that's the wrapper around our models that people use every day. And so we've gone in the space, in the blink of an eye, from not being able to contribute meaningfully to engineering to essentially being able to build autonomously very complex applications. And so this is a profound implication. Let's zoom way, way back and try to put this in context and understand what's going on. And to do that, we have to go way back to the beginning. Transistors were invented in 1947. And since then, we've all experienced the benefits of Moore's Law, that every single generation, the computing power doubles, and the performance of a given IC tends to double in about 18 months. And amazingly, this has held true essentially since the beginning of transistors, and it in some ways continues to be true today, although in different forms. And that, over the decades, has given us very powerful, ubiquitous computing. We all have these borderline supercomputers in our pockets. And also, this has given us incredibly powerful computers that are able to do machine learning and deep learning at scale. And that has given us intelligence, which is an entirely different kind of computing. It's complementary to traditional computing, but it solves different problems. It's not deterministic, it can reason, and it doesn't execute code. It kind of just uses this, the incredible power of these models to do cognitive tasks. And this is on a similar exponential to Moore's Law. This is as close as we've got to a natural law governing AI. It's called the scaling laws. And so in a very short period of time, it's given us very powerful models in the form of, I think Claude Sonnet 3.5 was kind of our big breakthrough. But we've continued to ship these relentlessly. And now Claude Opus 4.6 is the state of the art in coding, or Opus 4.7 now. And this has happened in just an incredibly short time. And the exponential that we saw there doesn't really do justice to what's happening. There are actually 3 different dimensions of improvement, and they're all accelerating at the same time. The first one is that the complexity of the problems that the models can engage with keeps going up. So this is longer context windows, many different instructions and having to follow them and navigate maybe inconsistencies, working with just very, very deep and complex problem spaces. The second one is that when you put these models in an agent, a way that they can invoke tools and work in loops, the running time of doing things that are productive keeps going up. There's a great benchmark called METR that maybe some of you have seen, but take a look at this. This also shows an exponential progression of the productive running time of agents. And then finally, the frameworks themselves keep getting more complicated. So when we shipped the first version of Claude Code, it was basically just a single instance running in a loop. It was just essentially one model, one context window. And over time, it sprouted much more complexity. It's got sub-agents, it can parallelize, it can have agents work against each other. And so if you put all these together, the practical rate of the doubling of capability is actually 7 months. It's significantly faster than Moore's Law. So even Moore's Law was a rapid exponential, but this is even faster. And so at Anthropic, I think we're true believers that this kind of goes to the sky. That's the pure exponential, let's call it. But there are some people that think that this might be a sigmoid. We might be on the fast part right now, but eventually this technology category levels off and kind of it is what it is. And there are still other people that think that we're headed for a hard ceiling. It's going to hit some point where it just goes bang and it doesn't get any better. And just for the sake of discussion, let's have an inquiry into what would happen if these skeptics are right. We can talk about what's possible today. And there are some very smart skeptics out there. None other than Yann LeCun, as recently as April 2024, stated that on the path to human-level intelligence, an LLM is basically an off-ramp, a distraction, a dead end. Not positive I'm coming with him, but this is a smart perspective. So let's briefly talk about agents, just so we're all on the same page. Agents are LLMs that have tools and skills. They can do things. They can change the state of the world in some way. And our co-founder, Ben Mann, had a great quote about this. This is just sort of an informal, off-the-cuff thing, but it really stuck with me. And he said, to understand when to use agents, you just think about when you would hire a smart person and train them to do something. And that kind of crystallizes the role of cognition in building systems around agents. Let's try to have a crisp definition for this. The best definition that I've heard, the one that helped this make sense for me, was that an agent is a large language model running in a loop. It continues to be called over and over. And it uses tools. It has the ability to change the state of the world around it in some way, to call out to another system, to write a file, to read a file, to do things that are beyond just the conversation. And it has a goal. And this is the critical thing that makes agents agents, is that they are invoked, they get a directive, they loop, they use tools, and they work until they achieve the goal or they hit their failure condition. And then they cease to exist, and you can invoke them again, or you can invoke many in parallel. But this is what sort of made it click for me, so I'm sharing it with you. And I got this amazing, very kind of glib piece of advice early in my programming career. Somebody said, to solve a problem using a computer, you think about how you'd solve it without a computer, and then you have a computer do it that way. And that sounds a bit silly, except that that's exactly how we organize agents. We're just replicating structures found in nature. We're doing things that humans have done for hundreds of years to organize themselves into groups that could do things. And so in this case, you have a leader, they have a team of executive followers, and as you go down the tree, you have increasing specialization, and in some cases, some adversarial relationships where they check each other's work or they work against each other for the greater purpose. And then you get down to ICs that are doing the implementation and the actual work. And when you roll all this up, it supports what I think of as the knowledge worker loop. And this begins with a process of research, accumulating all the information that you're going to need to solve the problem. And if you've ever done, for example, a Google search and accumulated tons and tons of tabs, you've done this research phase. You get a lot of raw material. And then you begin to shrink it down to the part that you care about and the part that's relevant. And you enter the analysis phase. You begin to do processing on it, you convert it into intermediate products, you try to understand it better. And then as you get comfort with analysis, you enter the synthesis phase, where you begin to create work products. And this is what knowledge workers are doing with or without agents all day long. They're collecting information, and analyzing it in some way, and then finally synthesizing an end product. And these are now real businesses. So if you haven't been paying close attention, over just 2 years, Cursor has become a $1 billion ARR company and probably is even beyond that now. GitHub Copilot, the revenue of Copilot alone is larger than the revenue of GitHub when Microsoft bought it. And outside of coding, there's some exciting stuff going on in legal. Harvey has generated almost $200 million in ARR entering 2026, and just in 6 months they've doubled it, and most of the American Law 100 uses them. But of course, there's one really exciting revenue stream happening now. And actually, this was dated as of March. So it already doubled in the first 3 months of 2026, and I think this number is out of date, but I don't know what the current one is. So now we can talk about the implications of agents running in these harnesses with extremely complex models supporting them. There's a great piece of research that we published on our blog a couple of months ago. In the same vein as having Claude code Claude AI, there's a researcher that has a litmus test for the ability of a coding model to do something really profound and important. And if you don't know anything about, we tasked it to build a clean room clone of the GNU C compiler, which is one of the foundational pieces of software in the world of open source and just the world of software. And all you need to know about it is that it represents the combined work of some of our smartest engineers over decades, and also that it must be absolutely perfect or it's useless. It must be perfectly correct, it must produce the compiled binary, even a single error renders it unusable. And so this is a perfect case where Claude can just continually work in a loop until it achieves the objective, which is to replicate GCC and compile byte for byte the Linux kernel in a way that matches the real GCC. And so it succeeded. Opus 4.6 was the first model that was able to do this, given the opportunity. And the way that it worked in practice was that somebody gave a looping version of Claude code a directive. The directive was build GCC. And it fed it in the event about $20,000 worth of Opus 4.6 tokens over the course of 2 weeks. And so it entered a self-iteration loop. The inner loop is Claude as an agent looping until it achieves its goal. And then the outer loop is just setting a new goal that makes incremental progress towards achieving the outer objective. And so this machine was able to accept the directive to build GCC and a whole lot of tokens, and then over the course of 2 weeks, it created a clean room clone of GCC. But we can generalize this a bit. It actually got a GCC complexity problem and $20,000 worth of capital, and it produced a solution of the complexity of GCC. And if you generalize further, it accepted a problem and some capital, and it delivered a solution. But we didn't stop there. There was another experiment that we ran in trying to improve the work products of these agents. And so in this case, the researcher established 3 roles: a planner that would decompose tasks into plans, a generator that would implement these plans and hopefully validate that they were working, and then an evaluator that would assess them as a software engineer or a design critique. And so if you put the planner, the evaluator, and the generator in this loop and you let them run, you have a harness that not only self-iterates, it self-improves. It assesses the quality of what it produces in a subjective way, and it tries to make it better by iterating. And so we can make one final tweak to this idea of the solutions machine, which is that if we add the iterative loop to make it better, you yield a self-improving solution. And this is very exciting. So there's this famous quote from Thomas Edison that genius is 1% inspiration and 99% perspiration. But what if it weren't? What if it was 99% the fun part and 1% the execution part, because we have these abundant execution resources? And so this is what I've been calling the great inversion, that the cost model of building enterprise software is beginning to flip. And there was this amazing editorial that a guy named Paul Ford wrote in the New York Times back in February, and he's a career enterprise SaaS guy. And he had this just absolute zinger of a quote as he was observing the experience of working with coding agents. He said, what if software wanted to ship? And I think for most of my career, and probably yours, software definitively did not want to ship. And part of it was the economics of it, that solutions were very expensive to build. You know, the tip of the pyramid, the fun part, the 1%, that's identifying and defining and scoping the problem, and then making the decision strategically that you're going to solve it. And most of the rest of it was a slog. It was implementation and validation, deployment, maintenance, and this led us to kind of an economic model for building enterprise software, which is if the whole pyramid of costs is not significantly smaller than the lifetime value of the area under the curve, of the yield you can get by delivering this to market, then you don't do it. But now the bottom of this pyramid is effectively gone. And we have a different pyramid, which is that most of the work is in that fun part and the exciting strategic part, identifying, defining, scoping, the decision making. And implementation is trending towards free. Of course, there's this famous quote, almost quote, from Bruce Lee, be like water. And what we're seeing here is a bit of a transition in computing to things that are more fluid. I've been in enterprise software a long time, and in most large companies, there's somewhere between 300 and 500 systems. Some of these are core platforms and they're systems of record. Others are extensions of those systems, or they're purpose-built inside the organization. Others maintain up-to-the-minute state, and they're the systems that know what's going on right now. And I think this might be a bit of a hot take these days, but these systems are here to stay, and there are a lot of benefits to having relatively stable platforms and stable workflows. But unfortunately, most of these systems barely talk to directly related ones, and even the tightly coupled ones can't access most of each other's data and their functionality. And in virtually no enterprises does everything talk to everything else that it should. And even if it could, it would be impossible to anticipate every combination. And so part of the dream that we've kind of collectively pursued as an industry is that eventually these systems will all talk to each other better, and that they'll integrate with more complementary systems, and cross-system workflows keep getting easier and more powerful. And this is something that, there are whole industries devoted to achieving. But integrations have a really interesting property, which is that they are self-specifying. Correct integration makes all capabilities of one system available to all other systems at whatever bandwidth both can support. And so to achieve this self-specifying outcome with something like the solutions machine, you really only need a coding agent in a dev loop that supports three things. First, it can self-iterate. Second, it limits its own ability to regress. And third, it limits its ability to do harm and have side effects. And so if you have a self-iterating, self-improving solution for building integrations, there is the beginnings of a path to delivering on this dream. And in a sense, what we're building here is the Omega integration, or the last integration, one continuous integration between enterprise systems. And of course, this continuous integration naturally integrates all systems with Claude, which can synthesize from them. And so from there, we can continuously adapt to changing APIs and changing upstream capabilities. And so this is the real quote from Bruce Lee. Be formless, be shapeless, be like water. And when you put water in a cup, it becomes the cup. Software implies something that retains its shape, but this is more fluid. Let's look at some demos that hopefully support that. First, I just want to show you a video that shows what, in that planner generator evaluator loop, what a 10th generation improved user interface looks like when Claude has a chance to really stretch its legs. This was entirely created by Claude in that loop with only the prompt, create a Japanese Sakura Festival page. And after 10 rounds of feedback, it is beautiful. And this one was just a prompt to create a Dutch art museum website. Version 1, it's fine. By version 10, Claude had created an OpenGL 3D rendered web page to give the gallery experience. And so this is the power of what you can achieve when you have the iterative cycle and you let the model self-improve what it's producing. So now I want to tell a bit of story of how this all comes together in the enterprise. I created a fake company called Centara. Hopefully that's not a real company. But let's imagine that Centara is a 100 million ARR enterprise data analytics platform. And it's just been acquired by a new capital partner, Meridian Growth Partners. And so this is the way that they were operating in the old days, as far back as 2025. They were building their board decks the old-fashioned way. The sales team would would draw on their system of record, their CRM, and they would build a narrative around how sales was doing great. And then the marketing team would do the same thing, and customer success would do the same. And so let's look at what they're presenting to their board. Things are going pretty well. The sales qualified to opportunity conversion rate blended between mid-market and large enterprise is 52.4%. That's running ahead of benchmark. Their quarter's above plan. They've got a good-looking pipeline. All's well in sales land. You know, it's mostly up and to the right, a little bit of variance in seasonality, but you know, it looks like it's a good picture. And the funnel conversion, as you go through the funnel map, it's looking good too. Things are running roughly on benchmark. And there's a similarly rosy story coming from marketing. We've got a improving mix. Marketing's big objective at Centara is to have more of the mix coming from large enterprise opportunities. And their marketing qualified to sales qualified lead conversion is looking good. Things are going well in marketing land. You can see that over time, the share of enterprise in this mix is growing. And you know, we've got a great breakdown of campaigns. And customer success has a great story as well. In mid-market segment, their 10-day trailing activation is 82.3%. That means that when mid-market customers do trials, they're usually implemented by about 10 days, 82% of the time. And you know, there's a note here at the bottom that enterprise trials are tracking a bit slower, but hey, you know, large enterprise is tough to work with, activations trail a little bit, nothing to worry about. And so this is, you know, a typical enterprise software company board deck. But Meridian is looking for something different. They want Centara to be able to deliver a board package once a week, and Centara is absolutely not set up for this. So the first thing they do is they wrap all of their systems of record with MCP servers so that they can talk to them with Claude. And what that lets them do is to ask Claude for things like, hey Claude, can you build a React version of the Centara board deck? And you can do it right on the fly because it's pulling all of the data from real MCP servers. And so Claude happily obliges, and it creates the board deck for Centara. And right out of the gate, we can see that there's trouble in paradise. As Claude is synthesizing information from across 3 different business systems and creating one narrative for all of it, what we see is that we're actually in a situation of declining growth, and it looks like it's structural. And Meridian is not really excited about this. And so we have to find some way to fix it. And the first thing that we can do is we can take advantage of Claude's ability to create extremely complex models just by working from source data. And so the next step is that we say, hey, let's build this financial model as a Google Sheet, and then we can go look at the model itself. So let's take a look at that. And sure enough, the picture is not great. If you forecast into the future, you've actually got a flat EBITDA and a roughly flat cash position, and this is not a great situation for an enterprise software company that ought to be profitable. But because Claude is able to look at all of the underlying data, it can figure out some recommendations at the synthesis between the 3. And the first recommendation, the one that it immediately pulls out, is that, let's blow this up a little, is that the enterprise trial onboarding is actually the source of this conversion problem. That thing that the customer success team, you know, probably in good faith, was minimizing, the enterprise conversion, trial conversion rate, that's actually the source of lower conversions in the part of the marketing mix that's increasing. And so Claude recommends that we change one of the underlying assumptions. Maybe we can go in here and we can look at our 10-day activation rate, which is kind of a dismal 37.6%, and let's see if we can model what this would look like if it were 70%. Let's go back to our dashboard now. Look at that, a much better picture. We have EBITDA climbing over time. For some reason, the cash position didn't update. But we also have the operating expense now beginning to diverge from the gross profit. So with one insight, that just by raising the enterprise conversion rate, we can get this company on the right track, that's the result of synthesizing all this information together. Now, we're here at Google Next, and you know, it's a bit embarrassing, a bit awkward that up at the top here, I guess we can't see it. This is actually an XLSX. And so as I was preparing for this, I thought, actually, I should follow my own advice. And so what I did was I asked Claude, hey, we actually don't have a great integration with Google Sheets and Google Drive. At the moment, we're sort of porting XLSX. Why don't you just build an integration for me, Claude? And so over the course of a couple of days and a little bit of prompting, Claude happily obliged. And so now I possess on this computer a MCP integration that lets me write Google Sheets and Google Slides. And so here we are. We actually have a great looking board update that was produced entirely automatically and is now suitable to put in front of the board. And again, it pulls out the key insights, does the same thing that we showed in React. And we've now automated this company. We've now created a set of integrations within Syntara that allow it to operate at the speed of thought, as opposed to the speed of being able to source these inputs to the decision-making process in the old-fashioned and kind of slow way. Claude's able to create pretty high-quality stuff, even with just a kind of dashed off, not fully stabilized, not production quality integration. And so this is an example of the power of these models sort of shining through in fairly simple harnesses and fairly simple frameworks. And as the models get smarter and smarter, the harnesses let them be more of themselves. And just as a sidetrack, there's a great article that everybody should read called The Bitter Lesson. And The Bitter Lesson lays out this idea that as models get smarter, efforts to try to coerce them and outsmart them and place them in ever more complex harnesses to wring just a little bit more performance out of them tend to backfire over time. And so from the Sonnet 3.7 to the Sonnet 4 generation, I think we cut our system prompt by something like 26%. And so this is an example of not getting too wedded and too excited about things that elicit just a little bit more performance from the models, because if you can let them express themselves in simple harnesses, you then ride that exponential up in performance. So all of this capability has given us 3 opportunities. I think of these as sort of the 3 doors that we can walk through. So the first opportunity that we have is that we can make our companies more profitable. We can grow our EBITDA. We can bank the savings from this. This is kind of the baseline efficiency idea, that you can simply have fewer people and more profit, and somehow that company is going to keep evolving. And maybe that'll be true for some places, but I think that that's the least ambitious of the opportunities that this creates. The second one is that you can parallelize. So having access to something like Claude Code, a coding agent, it doesn't necessarily mean that you can ship software 100% faster, because a lot of building great software is the decision-making process, is knowing what users want, it's understanding things. But you can create a lot more experiments and run them in parallel. And so this creates optionality for the business. If you run a lot more experiments, you can de-risk things quicker. You can build proofs of concept. You can find ways to create opportunity that you didn't have before. But a third opportunity is that you can make your products really, really good. And those of you that have spent time with coding agents, there's a funny experience that you can get into where once you've achieved your main goal, you can push it a little bit further. You kind of say, well, how good could I make this? How much polish could I put on this? How much more iteration would give me a useful result? And so the opportunity to make things that are really, truly great eludes a lot of us in enterprise software, because typically we ship when we hit the MVP or maybe just barely miss it. And a lot of times we don't come back to it, we don't improve it. And I think this is a missed opportunity in software, that the chance to make things that are beloved is what creates kind of generational platforms and things that people really enjoy using. I'll never forget the time when my previous company adopted Slack. And the way that we adopted it was that lots of people just decided it was better, and they liked it, and they started using it. And then through the magic of product-led growth, suddenly we were a Slack company. And so if we go back to this idea of self-iterating agents, that's the easy part. The tricky bit is designing the conditions under which this iteration converges on something that you actually want. And so even if integration is trending towards free, the harder part is knowing what to integrate. And how to make it elegant is not the easy part. And so if you kind of attach this back to the 3 pillars of Anthropic, there are some great opportunities that come from having this software capability. First one is that you can empower every employee. The second, you can supercharge software development. And the third is building these new revenue streams. And I know I said at the beginning that I didn't know what was next, but I'm going to try to speculate a little bit. I learned something interesting about Anthropic not long after I joined, which is that our model series Claude is named after Claude Shannon, who's one of the early pioneers of information theory. And Dr. Shannon, of course, is the originator of Shannon's theorem, which states that any particular information channel has a maximum capacity of information that it can deliver. This is the Shannon limit. And with the right encoding, you can approach that limit. And so if you kind of squint at the solutions machine, and you consider the ability of these systems to self-improve, to self-iterate, to generate user experiences on the fly, you can see the outlines of a new form of software. Fluid, continuous delivery of the full capabilities of any computing platform and any combination of enterprise systems, with personalized user interfaces for the long tail of tasks that exist at the intersection of systems and data sets that are outside the scope of core systems. And we can deliver this fluid computing at the maximum bandwidth of the computing environment, and that makes the Shannon limit the ability of the user to interpret it. And so computing becomes a continuous surface. User experiences that begin with natural language, and they deliver a mixture of polished, predictable enterprise workflows for common use cases and streaming user experiences for the long tail. Self-improving agents, many of them powered by Claude, are going to be at the core of this. And so these computing systems will deliver computing outputs at our maximum capacity to understand and to engage with them. And on that note, I like to think that Dr. Shannon would be proud. Thank you very much.